two dots are there, they are related to each other. Associative method, that means robot associates. See now the angle of view. In relation methods, objects are there, they are seen as a nodes or dots, and objects are correlated to each other. In associative method, now robot localize with that object with reference to robot and with reference to real life objects. In relational methods, with reference to real life objects. So object to object relation is taken. Associative method, robot is retracing the path. Robot is saying that building 1 is here from me and building 1 is there from me. In relation method, what we say that building 1 and building 2 is having some distance. So relational method and associative method. Now our next part is their landmark. As we say that in topological navigations, we have to define landmarks. Landmarks are nothing but identification. But how this identification occurs? It is like objects which are having distinctive features of interest. Objects which are having distinctive features. So that, for example, there is a McDonald's. So I can identify that is very distinct. That object is having special identity, right? There can be many landmarks. You can associate landmark with grouping objects. For example, number of trees are here. So landmark, that means it is the object which is having some identification type of features, distinctive features, statues, right? A particular shop, particular famous spot, so that you can remember that route, right? So that object is of our interest. Because of that object, we can give identity to our path. So we can have many such landmarks. Now landmarks are divided in two types. One is natural landmark and other is artificial landmark. Now this natural and artificial is not like man-made and given by nature or organic. There are different definitions are here, right? Now artificial landmark, that means set of features are added already, right? And they will be supporting for recognition, right? For example, highway signs, right? So these are already there. There are arrows for navigation. So these are artificial landmarks. Robot need not to define it, right? Many a times, whenever we are having driverless car or navigation to the robots, we avoid artificial landmarks because they might be changing time to time or they are not permanent, right? Most probably in navigation, we have to rely on permanent landmarks. Remember that when you roam in the real world, how many objects you are passing? When you are moving on the road, there are numerous n objects around you and you are finding path. Your brain is trained to find that path. But how robot will navigate? Even in factory environment also, whenever bigger factories are there, like uh, Amazon storage, where you can find that all these robots are automatically picking up objects and placing on the right side or conveyors, right? Or in a factory environment, whenever robots are moving, at that time you can see people are crossing, right? The colors of wall changing, lighting changing, many things are happening. So all the time, even if you add many symbols, remarks, their accessibility is questionable. That's why artificial landmarks generally avoided, and we have to create our own definitions for particular part. Remember again, if you are having very long distance to travel in a factory environment or in a real life environment, you cannot place sensors everywhere. So somehow we have to work on high range sensors like radar, lidar, or camera. So for a limited floor of the factory, just one room, two room size, or even a workshop size, things are easy. But whenever factory is bigger, whenever bots are really moving on the floor, or whenever driverless car or any bot is moving in a known environment or unknown environment, like museum, right? At that time, you can see distance traveled is large, and we cannot use sensor based paths every time, even though they give great accuracy. But at that time, we have to some way, we have to define the actual landmarks. That is what importance of topological navigation. Now artificial landmarks are already given signs, right? You can add them but give some less priority. Natural landmarks, that means this configuration is existing and that will not change. This will be always there, right? This will be like temple, tree, or that particular part. So it is having special feature, different colors, very quick identification, because everything is happening in real time, right? For example, arrows are there, then again we have to take image of arrow, then try to match and go ahead. So that's why we want certain different things. So within a shot we can arrange identify that landmark and we can go, so perception can be done very fastly. So these are artificial landmarks and natural landmarks. So landmarks must be recognizable. They should support the task dependent activity. Good landmarks are always having the illumination instead of power failure, or they can perceive in all qualities, day, night. It is having very distinctive features and again unique features. That is what good landmarks are there. Gateway is the second part. Now this is related to the path or routes. So whenever we are traveling, gateway where different junctions are happening. So we enter from here. So you are having multiple paths or multiple ways to go ahead, right? So here it is the opportunity to robot to change the direction. So path planning, map making, here gateways are very important. Gateways are very important for optimal path planning, desirable path planning, optional or multiple optional path planning. These type of things can be defined with gateways. So gateways many times in a metric path planning can be a floor plan or factory floor area, that plan is there. So we can draw relational graph. So this is what actually floor plan. This is how actually factory floor is there. Now we can draw a relational graph and we can associate where path is located. Now see that first method in relational method for topological path planning is this relational graphs, where we can define each of corner or each of landmark as a nodes, right? Similarly, your goal location can be nodes, and wherein the edges will be navigation paths or navigation route. So this was our overall floor plan. Now we decompose that floor plan as a connection of nodes. So this is said as relational graph. So in relational method, all landmarks are now replaced by the nodes. There will be connectivity between nodes. This is how they related to each other. Of course, that is defining order also, because this is first node, second node, third node, fourth node, likewise. So see, here we are entering and then we are going over here, correct? So landmark 1, 2, 3 and 4. So we relate each other and associate each other. Another method is spatial hierarchy, where topological connectivity can be assigned. Many times if you calculate the different type of connections, and you can calculate distance also. Relational method use on spatial hierarchy, so where topological connectivity can be find out, and then local control strategies can be decided with that. Sometimes you can find out path with different other methods also, like distinctive place, like neighborhood, and you can find out obstacles with that path. So neighborhood boundaries, so this wall and this wall, so where exactly I have space to move. So this is what called as neighborhood method. So that is what landmarks, right, could connect nearby region, and this region is a movement region. So look at this neighborhood boundary where we can have, so neighborhood concept, that is distinctive place where conflict may occur. Now associative methods where we can have sensor observations, or we can have association, we can have association of different landmarks. Of course associative methods are generally higher end methods where we need sensors, we need camera or radars, where perception can be done. There are many methods in associative methods, like associative methods can create view from top or 3D views. Associative methods can be creating image signatures, and perception can be there. So perception can be there because there are distinguished features over there, so you can have that parts. So in associative method, first method is visual homing. Remember we are discussing topological path planning, wherein relational method is there, associative method is there. In associative method we are discussing visual homing. In visual homing, now what we are doing, we are creating. Now what he was saying, Nelson, this is a paper we are referring, right? There are two papers in this visual homing. So we have now a view from top, or we are having camera enabled system, and now we find image signatures, and we to try to recognize the real world, right? Again we can find distances from this real world also. For example, when pan of camera moves, we can recognize the object from this distance. So this is what associative method is. Signature and trying to match that particular object, so that we can compute distance also, how much long or how much uh, near the object is, or particular node is. This type of calculations we can do in associative methods. Why associative? Because robot is associative with this associated with this particular node. And again in visual homing we use camera, and we are going for image signatures for the same. Now another aspect or another method in associative method is call nav system. Here now we are having enough uh, hardware or enough sensor mechanism, wherein we can look from above, or we can have sensors that can create 3D view, and from top you can see all the objects and create map of the landmarks, right? And then we can try to manage. This method is can be used in metric maps also, or in topological also. In topological navigation, each of landmark will be associated as a node, Now you are having clear views, and every time you can take satellite help, or you can have lidar or radar, right? In some of complicated methods, you are having drone which will be helping to the robot. So drone is flying from above. Right now it is happening on Mars, right? Integrative helicopter or drone is there, so that flies and then it takes topological map, and then robot moves as per that information. So Colna system is that basic principle in associative methods. Okay, we